Assalamualaikum and very good day. We are from group 7 and we are going to present about advanced encryption standard. Our group consists of 5 members, which is Kamalia, Christina, Fairuz, and me, Amirul Ashraf, and last Syafiqah Nabila. Okay, for the definition is the advanced encryption standard is a cheaper, which is a process for converting raw information into something that cannot be read and known as encryption. The approach uses a known external piece of information known as a key to modify the data in a unique way. As an example, consider your computer login or the password to your bank account. Furthermore, the technique is reversible, which means it may be used again to return the information to its original form, referred to as decryption. The AES algorithm can encrypt and decrypt data in 128-bit block utilizing cryptographic key of 128, 192, and 256 bit. Okay, next is for the introduction AES. The US government used AES as a symmetric block cipher to secure sensitive data. AES secure software and hardware data globally. It's vital for government computer, cyber, and data security. AES is a data encryption technology created by NIST in 2001. The US selected global AES. It is supersedes the US government 1977 Data Encryption Standard DES. AES is based on the regional encryption, which was invented by two Belgian cryptographers, John Diamond and Vincent Rijman, who proposed it to NIST during the AES selection process. The regional chipper is a group of chipper with varying key and block size. However, AES only choose 3 chipper with one block size of 128 bits and 3 key lengths of 128, 192, and 256 bits. This is 3 AES that consist in this AES, which is AES 128 with a 128 bit key and the other.
Next is the AES application. AES encryption is widely used in a variety of contexts, such as commercial products, wireless security, web browser, and federal government department. In commercial products, AES encryption is used as the support for native processors, VPN application, and operating system components. Next, AES is applied in wireless security to authenticate routers and clients. Furthermore, web browser is one application that makes advantage of the AES encryption. AES is essential in protecting the website server authentication from both the client and server sides. Additionally, in order to secure classified and restricted unclassified information at rest, several federal government departments implement the Federal Information Processing Standards with the AES encryption algorithms.
Okay, now I will continue about advantage and disadvantage of AES. Okay, first we go to the advantage first. First, more secure security protocol. Second, more resistant to hacking. Third, most widely used commercial and open source system worldwide. 4. Most widely used security protocol for a wide range of applications. 5. Very safe protocol. And lastly, for advantage is nobody can access your personal data. Okay, next we go to disadvantage of AES. First one is simplistic algebraic structure. Second, block encrypted exactly the same way. Third, software implementation is difficult. 4. Performance and security difficult to implement in software. And the last one for disadvantage is cause a cryptanalytic attack. So now we go to general explanation. For the general explanation, the Advanced Encryption Standard AES is a symmetric block cipher, which is AES is used to encrypt sensitive data in software and hardware all around the world. It's critical for government computer security, cyber security, and data security. For AES, is use 128 bits as input and produce encrypted ciphertext in 128 bits. AES use bytes rather than bits to conduct operation. The cipher handles 128 bits or 16 bytes if incoming data at a time, since the block size is 128 bits. To generate ciphertext, AES employ a substitution permutation or SP network with multiple rounds of number is determined on the key size utilized. A 120-bit keys require 10 rounds, and 192-bit keys size require 12 rounds, and a 256-bit key size require 14 rounds. And each of these rounds require a round key. However, because of the methods only accept one key, this key must be extended to obtain each key for each round, including round 0. So now we go to general explanation for the step. So the step has two, encryption process and decryption process. So the first process is byte substitution, or we call it sub-bytes. And the second one is shift role, third mixed columns, and the last one is add round key.
AES algorithm pseudocode. The pseudocode starts with print a statement to tell user that there are two options to encrypt a plain text in AES. Next is to print choice 1, which is the AES string encryption, and print choice 2, which is the AES password-based encryption. Next is to ask user to choose either choice 1 or choice 2. If choice is 1, while rerun.contains yes, means that if user answer yes, then this piece will run. Then the user enter message in plain text. Next, with the AES string encrypted data and string decrypted data method, encryption and decryption process is performed. After the process run, the encrypted and decrypted data is printed. Next step is to ask user if there is a new message. Else, which means that when user choose choice 2, while rerun.contains yes, print the statement of first part, which is messenger to receiver. Then ask user the message to encrypt. Then ask user for the secret key. Next, encryption process is performed, which is the string encrypted string method. Next is to print the statement of second part, where receiver wants to read the message. Firstly is to display an encrypted message. The string decrypted string method, which is for the decryption method, is performed. Then the decrypted message is displayed, and then ask user if there is a new message. If no, then the program will end.
Okay, for the next part is about mathematical representation. Now, let's begin with a construct from abstract algebra known as Galois field or finite field. A field is a set allocation of items with operations that operate on the set and behave in the same way as addition, subtraction, multiplication, and division. In other words, the operation meets certain conditions that also apply to addition, subtraction, multiplication, or division over rational number. In reality, these four operations with rational and real number qualify as a field. The finite qualifier simply indicate that the set has a limited number of items. Galois field GF P exponent n has P prime and n positive integer elements. GF bracket 8 or GF 2 exponent 3 contains 0 through 7. Next, GF 2 exponent 3 contains 0, 1, 2, 3, 4, 5, 6, 7. Each can be expressed similarity as 0, 1, 2, 2 plus 1, 2 exponent 2, 2 exponent 2 plus 1, 2 exponent 2 plus 2, 2 exponent 2 plus 2 plus 1, where x equal to 2. Okay, this is a mathematical representation for addition and subtraction. Consider combining GF, P exponent n, A and B. Start by expressing them as sum of power of P. For each coefficient in a P, BK in B is at. So this is the formula for addition and subtraction. The addition and subtraction use a same formula except the plus and minus value. Okay, so let's look for the example. We use 74 plus 20c in GF 34. We use the formula for addition, and after calculate we will get answer 70. Okay, next is for mathematical representation about multiplication. To multiply A, P and BP in GF P exponent n, find a third polynomial MP with at least n degrees. MP is known as the irreducible polynomial. To multiply A, P and BP in GF P exponent n, do the following step. First, multiply AP and BP as usual. Reduce the modulo P coefficient of the resultant polynomial. Third, reduce the full polynomial mod MP. This is done to keep our final answer less than P exponent n. Okay, this is for mathematical representation, the multiplicative inverse or division. The multiplicative inverse of a polynomial AP is a polynomial BP with the multiplicative inverse AP multiply BP mod MP equal to 1. The inverse of the procedure above can be used to find multiplicative inverse. Multiplying the first operand by the multiplicative inverse of the second is all that is required for division.
Okay, next I will explain about a detailed explanation of the algorithm work with illustration using figures. Okay, next I will explain about a detailed explanation of the algorithm work with illustration using figures. Okay, AES is an iterative encryption. It is built on a substitution permutation network. It is made up of a sequence of connected operations, some of which require replacing input with certain output and others which require moving bits about permutation. So, this is the figure that shows a schematic of the AES structure. And for the encryption process in AES, each round is made of 4 sub-processes. That is add round key, sub-bytes, shift row, mix column, and add round key. Okay, for the step-by-step of the algorithm work, the substitution of bytes. The 16 inputs bytes are replacing by looking up a fixed table in the design. The ultimate result is a matrix with 4 rows and 4 columns. Next is the shift row. The result is a new matrix with the same 16 bytes. but moving in connection to the previous one, any entires that are dropping off are reinserted on the row right side. The next one is column. A different mathematical function is used to modify each 4 bytes column. This technique takes 4 bytes from one column and produces 4 entire new bytes that replace the original. As a result, a new matrix with 16 more bytes is created. Next is add round key. The 16 bytes of the matrix are considered as 128 bytes and are XORed with the 128 bytes of the round key. The output will be the chip text if this is the final round. Otherwise, the 180 byte result is interpreted as 16 byte and the produce is repeated.
Hi, Assalamualaikum. My name is Shafika Nabila and I will present part implementation of algorithm by Java. So for our first file, which is AES string encryption, there are 4 parts. For part A, it will declare all variables used in this file. Variable secret key was imported from javex.crypto.secretkey package. It is an interface for secret, which is symmetric keys. The purpose of this interface is to group and type safety for all secret key interface. For in key size and data length, we will set it to 128 as it will store data and key to that particular size. Cipher encryption cipher that is imported from class javex.crypto.cipher that provides the functionality of a cryptographic cipher for encryption and decryption that we will use in other parts. For part B, the purpose for init method is to generate a new key using key generator that was imported from a class javex.crypto.keyGenerator. On the first line in this method, it will declare using a specific algorithms. Hence, for our case, we will use AES algorithm. Based on Java documentation, key generator has 5 algorithms, which is AES, DES, DES-EDE, hashmag SHA-1, and hashmag SHA-256. Second line is to initiate the size of the key by using variable declared in part A, which is key size equal to 128. The last part is where the key is generated using key generator key method. Part C will show the encryption process. First line shows how to convert string data to bytes and save it in the data in bytes variable. Next, by using the encryption cipher variable declared in part A, we will set it to AES/GCM/no paddings algorithm. GCM is Galois counter mode. Line 3 encryption cipher will use a method init that needs 2 parameters, which is the op mode and key. Encrypted byte will receive output from method doFinal that will encrypt in a single part operation or finish a multiple part operation. Finally, this method returns randomized alphabets, numbers, and symbols to show input has been encrypted. Last part in this file is part D, which is decrypt method. Decrypt method need the parameter string encrypted data. Line 1, data in bytes will save data after base 64 decodes encrypted data. Next, we will set the decryption method into decryption cipher. We will be using the same algorithm as the encryption method. Decryption cipher will use a method init that needs 2 parameters, which are op mode and key, 3 parameters, which are op mode, key, and algorithm parameter. To get algorithm parameter, we will set it through new GCM parameter spec. Decrypted byte will receive output from method doFinal that will encrypt in a single byte operation or finish a multi-byte operation. Finally, this method will return a string that shows the original input. Next file is AES password base. In this file, it contains 4 parts. Next file is AES password base. In this file, it contains 4 parts. For part A, declaration of all variables that will be used in this file. Secret key was imported from javex.crypto.secretkey package. It is an interface for secret symmetric key. The purpose of this interface is to group and provide type safety for all secret key interface. Byte key used to store keys in bytes. Part B. This method is to set key with input or password given by the user. Message digest are secure one-way hash function that take arbitrary size data and output a fixed length hash value, and it has two algorithms such as SHA-1 and SHA-246. For this method, we will be using SHA-1 to digest the key. Secret key will store keys that are encrypted by using AES. Part C, encryption method will need data or user input and a secret key that has been generated from set key. Same as part B on the first file, cipher.getInstant will let us set our desired algorithm. And for this file, we will use AES/ECB/PKCS5 padding. Cipher will use a method init that needs two parameters, which are output and key. And lastly, it will return output from method doFinal that will encrypt in a single part operation or finish a multiple part operation. For the last part in this file, which is a part D, decrypt, which is need a parameter string, is a method that will decrypt a message by using password from user input. This method will ask the user to enter a secret key in order to decrypt the message and be able to read it. The secret key must be the same secret key that is used to encrypt the message. On line 10, set key, secret key is to proceed to method set key in part A. Then after retrieving the secret key in byte form, we will set an algorithm used to decrypt the message, which is the same algorithm used to encrypt the message. Then lastly, it will return output from method doFinal that will decrypt in a single part operation or finishes a multi-part operation. Our last file is AES main class file, where all methods from above two files are called to become a complete implementation. In this file, we will start by letting the user choose what kind of encryption in AES the user wants to use. If a user wants to encrypt using string encryption, they will have to type 1 or else. If the user choose 1, then the main class will call the string encryption method, and if choose 2, the main class will call password-based encryption method. Each method will ask the user to enter their message. The difference between these two methods is password-based encryption will ask for a secret key from the user, while string encryption will automatically generate the secret key for its own use. Next part is explanation of program implementation with clarification of inputs and outputs. To show the implementation, we will run the program. So firstly, the application will ask user to choose between string encryption or password-based encryption. So for the first demo, I will try to choose string encryption. So we will enter message, and then the application will encrypt and decrypt the data, as you can see on the screen. Next, we will see for the second option, which is password-based encryption. So for the password-based encryption, it will need user to enter the message and the password to encrypt the message. So I will enter message, hi, this is a secret message, and the secret key is and then the application will encrypt the message, and it need the user to input to enter the secret key to encrypt the message. So you can see the message is there after the user enter the password.
For the conclusion of AES is the use of internet and networks is quickly rising. Every day, a large amount of digital data is exchanged between users. Some data is sensitive and must be kept safe from attackers. Encryption methods are critical in preventing unwanted access to original data. To encrypt data, a variety of algorithms are available. One of the most efficient algorithms is the Advanced Encryption Standard, or we call it AES, which is extensively supported and used on both hardware and software. With a 128 bits block cipher, this technique can handle multiple key sizes such as 128, 192, and 256 bits. Okay, that's all from our group. Thank you.